In the last few weeks, I've been helping my customers decide how to migrate their legacy port groups across to NSX-T controlled secured segments, whether these are VLAN backed segments or overlay segments inside NSX. So let's quickly go through and just work out the lab topology we have right now we're dealing with. Draw out my layer 2 environment here. So inside my lab environment, I have a existing legacy port group on VLAN 123. And attached to this, I have a pair of VMs. So VM1, VM2 are both on here, so they're presented to the network on VLAN 123. In the middle of my network is my trusty MikroTik core router, let's call it, which is providing all the layer 3 gateway capabilities, and it's connected via a trunk interface into the network. So VLAN 123 is presented to the MikroTik. It's providing routing on VLAN 123, and we're using 10.123.0.1 as a default gateway. So this address resides inside the core. All traffic and forwarding has to go through this gateway device. So if we now look at how we can actually migrate this inside NSX, the first thing we can look at is using a VLAN backed segment. So a VLAN backed segment inside NSX presents tagged Ethernet frames to the network in exactly the same way that an existing port group does, but it provides all the benefits of embedded security directly inside the VDS. So everything from stateful firewalling, IDS, IPS, URL filtering, anti-malware, etc., all directly enforced inside the VDS adjacent to the workloads. Let's go through and validate how this is configured. My existing port group I'm using here is called Purple vSphere. I have two VMs on here as well, so Ubuntu 1 and 2. I have a machine here. We'll just should have ping internet from here. Great, that's working. And all right, so that's very standard, very vanilla port group inside vSphere. If we jump into NSX, I have my topology I can look at here as well. So, okay, we're not going to touch on that yet. We'll dwell on the topology stuff shortly. But to make an NSX VLAN backed segment inside NSX is very simple. Add a segment, give it a name. Do not attach it to a gateway, and simply select a VLAN transport zone. No IP addresses here. The gateway address still resides on the core router. VLAN 123, save that. Nothing else to do here, except jump back into vSphere and have a look. We now have this new purple NSX VLAN has appeared. So it too is using a VLAN ID of 123, much like our existing environment is. So leave our ping going here. Let's speed it up. 1 ping packet every millisecond. All right, let's take our workloads here from vSphere workgroup and migrate these VMs and move them to our new network. Finish that. Right. Okay, didn't lose any packets. There was a bit of a slowdown on one of them. Okay, so great. 0% packet loss on a migration into an NSX VLAN backed segment. So our VMs have been moved across. As you can see, there's a little N icon here to dictate this is controlled by NSX. Any workload attached to this type of VLAN backed segment now immediately gains all the benefits of security enforcement, so layer 4 through layer 7 capabilities of the VDS. So we've successfully managed to migrate our workloads into here, and we haven't had to change the underlying layer 2 or layer 3 topology of the network in any way. So the next stage now is to go and look at how we actually move these workloads across to an overlay segment. So we'll create a new overlay segment, and this time we'll be moving the layer 3 gateway from here and moving it to a distributed capability across the VDS. So we have some innate capabilities inside NSX. So we're going to build a tier 1, and we're going to call that purple tier 1. And that will be connected to our pre-existing tier 0 router called peering, which has a BGP session into my lab environment. So BGP. Could be OSPF, or you could use static routes if you need to. The IP address of my peering relationship here is 1, which we'll look at later on. So our workloads now are going to move across into here, which means the layer 3 gateway address will be removed from here and now will be present directly inside the BDS, adjacent to the workloads. Let's go through and configure that. The first thing we'll do is quickly just look at the routing table I have inside my environment. So 10.123.0.0 is directly connected to my purple VLAN inside my lab routing environment. Jump into NSX here. We're going to make our tier 1 gateway purple. It's going to be connected to peering as it was in the diagram. Save that. Let's do a couple more things in here while we're here. So we'll turn on DHCP. My workloads for demos use DHCP local. And we're also going to ensure that we advertise our connected routes, otherwise they will not be present. Close that. Let's jump back in the terminal here. Okay, we don't have the 10.123 network here yet because we don't have a segment created inside NSX. So jump back into NSX, add a segment, purple NSX overlay. And we're going to connect that to our recently created purple tier 1. And this time we're going to choose an overlay network. And the 10.123.0.1 gateway address here, which is where we're going to move it to, and turn on DHCP as well. Okay, so it's done. Nothing else to do here. Let's jump back to the terminal. Okay, BGP has now advertised that route as reachable via 10.64.8.1, which you'll recall is the IP address of my tier 0, the embedded edge VM sitting inside the tier 0. So I now have 2 ways to reach that network, which could be a bad thing, but connected routes are obviously preferred before BGP routes. So I'll be using my locally connected interface here to provide routing. So now we can move our workloads across. So we're going to jump back into the browser here. Going to go across here. There's a few things we have to do to make this happen. I'm going to migrate our VMs across. I'm also going to jump onto my lab environment here and disable the connected interface as well. So in a MicroTik, we disable that by pressing this X here, which actually friendly or kindly enough disables interface for us really quickly. So it removes that from the routing table. So let's move VMs from here to our recently appeared purple NSX overlay. What I will do is jump on the VM again, and I'll run that ping again. So by running a ping every millisecond, we can quickly work out our number of seconds we actually impact any forwarding during a migration, without resorting to using expensive gear for testing, obviously. So let's right-click on here, migrate VMs. This time I'm going to go across to our overlay network. I'm going to select 2 VMs. Next. So what I will do is I'll quickly jump back into the MicroTik and disable it interface as well. So we'll do both those at the same time. Disable that. Jump on the VM. Okay. We briefly lost something there. So, okay. We lost 8 packets. So about 8 milliseconds of downtime for that migration. Jump back in here. Okay. Overlay now has my Ubuntu VMs on it. Let's go look at the routing table. So when I disable the interface, it removed the connected route from the routing table. The only way to reach this network now is via 8.1. 8.1 is my T0 here. So traffic has now been drawn into the T0, forwarded across the overlay to my workloads, which I've now have attached over here. So my workloads now reside here, not here. So I now have the embedded firewall sitting here as well, obviously, just like I did on the VLAN Backed segment, where I can now enforce security. Right, that's it for the migration scenarios here. Once again, if you've got any questions, please reach out to me. Look forward to hearing from you. Thanks. Bye.